Okay, let's jump right into this. If you've ever tried to wrap your head around advanced programming concepts, you know that honestly, the best way to learn is by rolling up your sleeves and unpacking a real, tangible project. Today, we're taking some seriously dense Haskell concepts and demystifying them by anchoring them to a practical, real-world task. We're going to generate PDFs using the Typst format and Pandoc. We're pulling all this from a fantastic developer log about building an ebook generation tool. It's super practical, and trust me, by the end of this explainer, these seemingly wild architectural choices are going to make perfect sense.
So, to get us to that final PDF, we've got 4 main milestones to hit today. First, we'll tackle the documentation dilemma. Second, taming the namespace. Third, understanding the PandocIO monad. And finally, we'll wrap things up with the magic of defaults.
All right, starting off with Section 1, the documentation dilemma, navigating the developer's initial struggle. Before we can even think about writing a single line of code for our PDF generator, we really have to understand our tools. And that brings up a massive hurdle. I mean, if you've ever stared blankly at Haskell type signatures, you've probably asked yourself, why is Haskell API documentation so incredibly challenging? You're just trying to build a basic tool, but getting into the libraries feels like scaling a sheer cliff face.
The author of our source material makes this really fascinating observation here, contrasting Haskell's documentation directly with Elixir. Now, Elixir, it basically sets the gold standard with its XDoc tooling. It's highly readable, it's inviting, it's just really practical. But Haskell, it completely lacks those practical examples. The writing style across its library APIs is, well, it's incredibly dense. If you're a developer just looking for a quick win to get your project off the ground, that density is a massive roadblock. But instead of just throwing in the towel, the author shares this brilliant, totally pragmatic workaround.
Instead of trying to read the documentation cover to cover like some giant textbook, you can use a super simple 3-step strategy. First, just have an AI bootstrap a really small functional code snippet for you. Second, use that exact snippet as your foundation, like your working prototype. And third, just tweak that code line by line. Seriously, this is where the magic happens. You break things, you fix them, and you actively build your mental model of the Haskell ecosystem without getting totally bogged down in dense manuals. It's such a great hack for rapid learning.
Moving right along to Section 2, taming the namespace, organizing imports effectively.
Okay, so now that we actually have a strategy to decipher the code, we need to start pulling in some heavy-duty tools, like the text-pandoc module, to handle all our document conversions. And this triggers that classic internal monologue every Haskell developer goes through. To qualified or not to qualified. It sounds a bit like Shakespeare, right? But it's actually a super crucial architectural choice about how to safely bring external code into your working file.
Look, if you just import everything unqualified, you literally have no idea what functions are being dumped into your workspace, and that is a recipe for massive confusion down the line. So what do? We use a hybrid approach. You import your types unqualified. Why? Well, it keeps your type signatures looking super clean and readable. But, and this is absolutely key, you import your functions qualified. You do this to completely sidestep namespace clashes, especially with the default prelude module. It really gives you the absolute best of both worlds, totally clean code and a rock-solid safe namespace.
Let's hit Section 3 now. Understanding the PandocIO monad, contextualizing the abstract.
To actually run the Typst engine and pump out our ebook, we have to step into a highly specialized environment. Now, if you've messed around with Haskell before, you're probably instantly thinking, wait, why not just use the normal I/O monad? We're literally just writing a file, right? Why on earth do we need to introduce a whole new monad just for Pandoc?
Well, what's really interesting here is the definition of the thing itself. PandocIO is essentially a customized, souped-up version of the standard I/O wrapper, but it is purpose-built from the ground up to handle Pandoc's crazy complex internal state and all its specific error-handling quirks. It basically gives us a safe, totally predictable context tailored specifically for document conversion.
The core thing to remember is that when we're generating a PDF using Typst, we're not just shuffling basic text around. Think about what we're actually doing. We're hitting the file system, we're calling out to external engines, and we are literally executing the Typst binary right on our machine. Those kinds of heavy lifting actions absolutely demand the specialized wrapper of PandocIO. It guarantees that if something goes sideways during that execution, Pandoc can actually catch the errors gracefully within its own internal system. So it's not just extra boilerplate, it's a critical safety net.
And that brings us to our final milestone, Section 4, the magic of defaults, streamlining the workflow.
So, we've got our Pandoc context all set up, right? But now we want to actually avoid writing a massive wall of configuration code. Now, listen, if you're coming to Haskell from something like Python or Elixir, you've got to completely reset your brain for a second here. In Haskell, specifically in this context, the def keyword is absolutely not a function header. It's not defining a new method at all.
Actually, def is this incredibly powerful tool pulled from the Data.Default module, and it's used to set default values polymorphically. Think about it. If you went with manual specification to set up your writer options for Pandoc, you'd be stuck typing out every single field manually. It's tedious. It clutters your whole file. Nobody wants that. But with the Data.Default override, you literally just drop in def. The compiler is smart enough to look at the context and go, oh, def means writer options here. So you start with def, and then you only explicitly override the exact setting you care about, like swapping out the writer template. It's just so elegant, and it completely saves you from managing dozens of totally irrelevant fields.
Which leaves us with a really fascinating thread to pull on. Think about it. We've bypassed the dense docs, we organized our imports, we successfully navigated the PandocIO monad, and we elegantly configured our writer options to accept a template. So the big question now is, how will templates transform this output next? Like, what kind of visual magic can we actually pull off in our ebook by feeding custom Typst templates into this beautifully structured Haskell code? I hope unpacking this project gave you the confidence to tackle these kinds of concepts in your own builds. Keep experimenting, keep building, and I'll catch you in the next explainer.